In this video, we're going to be talking about cross-origin refer redaction and why it's so damn complicated compared to everything else that's super simple on the web platform. So let's get into this. It's just a 13 slide or so presentation that I put together that we can quickly rip through. But before we try and understand cross-origin refer redaction, we need to understand exactly what the concept of a same origin request is. So we have a request and we need to determine whether it's bound for a different origin, which means we really need to compare two things. Number one, where it's coming from, where the request is coming from, and number two, where it's going. We make that comparison, we can determine whether the request is indeed crossing the origin boundary. Here's a quick example of us doing this in the fetch standard. So we compare two origins. Let's look at these individually. So the first origin is request origin. Well, it's pretty generic. We'll get into exactly what that means in a little bit. And the second one is the request current URL's origin. So the current URL is really just the destination URL of the request, the resource that the request object is currently standing for. And we compare this whether it's same origin, which is just the equality comparison of the bits of the origin struct, with the request origin. So okay, so what is a request origin? This is the part that must be, determining where the request is coming from. So an origin is either the string client or an actual origin, of course. We default to client so that we don't actually have to manually set this everywhere, and then at some point in the fetch algorithm we resolve this client string to the actual origin that we want to use for real comparison. So where does this happen? Well, we can see right here. Step 9 in the top level fetch algorithm in the fetch standard is where we say if the origin is this client stand-in placeholder string, then we're going to just swap it out for the client's origin, because that's really what we're standing in for. Okay, so the question is then what's the client? And the client is in fetch, I believe it's an environment settings object, or I think or null, of course. And if it's an environment settings object, then so what is an environment settings object? This is basically this polymorphic interface that HTML standard provides. It's polymorphic because its values differ depending on whether it's a settings object for a window or a worker or a worklet, or I think that's it maybe. So we'll just look at the definition of window here for simplicity. It has, adheres to this API contract of providing a module map and a realm execution context, and of course an origin. And in this case, the origin, the value of the environment settings object origin member, is just the Windows associated documents origin. So the origin of the actual document that's hosting. So we go back to this example, and really what we're comparing is the requests, the origin of the document's URL that the request is coming from with the current URL of the request, aka the destination where this request is bound for. Okay, that makes sense. We should just be able to use that everywhere on the web, right? Like just determine those two just compare those two things to determine whether a request is or is not same origin. But that's actually not the case. That would be way too simple. So welcome to the web platform, where we have a separate layered definition called a same origin refer request. This is present right in the refer policy standard that I edit. We see in the key concepts and terminology section that we have this definition of a same origin refer request. And if it's a different definition, we must be comparing two different origins, right? And that's the case. So the second origin that we compare here is actually the same as last time, right? The origin of request current URL. Okay, that's cool. But we have a different baseline, a different origin that we're comparing this to determine where the request is actually coming from. In this case, it's the origin of the request refer URL. And so what is the refer URL, you might say? Well, in the refer policy standard, we have this determine a request's refer algorithm, where we actually set this refer source, which is used for the refer URL later on. More times than not, this is just the document's URL. So it actually ends up being the exact same comparison as the normal traditional fetch standard same origin comparison. It's almost the same every time. But sometimes the request's refer string can actually be set to just a completely separate out-of-band URL in which case the refer source is indeed that URL, the refer string. So that's when this comparison, the comparison that we perform in same origin refer request, is different than the traditional same origin comparison that we perform in Fetch and a few other places, many other places, the rest of the web platform really. That's when this is different. So when do we actually see this in practice? That might be the next question. We have these two different definitions, and when do we actually, when are they relevant? When do we come across a manually set refer string such that, you know, the outcome of these two different definitions will be different? Here's a complicated looking diagram, but it's actually not that bad. We'll walk through it slowly, and we can actually see exactly how this happens. So let's say we've got this top level page, a.com, page HTML. It has a refer policy on it set to same origin. So we can say that this is set by the response header of the resource or a meta tag in the markup. This top level page creates a module script request for b.com script.js. So it goes cross origin, and we can look at the request properties here. So the current URL is b.com, obviously, that's the b.com script.js. The refer string is, in this case, the document's URL, okay, a.com page HTML, and then the origin is a.com. So in this case, the refer string and the client origin are the same. We can, you know, either same origin definition would compute that this is a cross-origin request. We would not send a refer header and so on. But if this module script fetches another module script, then we kind of run into some sneaky logic in the HTML standard, where we see here in this bubble number 2, module descendants actually have their refer string set to the parent's module script's URL, or what's called the base URL in the spec. This is because we want the parent to kind of behave like this lightweight client, where it can sort of grant a few properties, in this case the refer string, to some of the sub-resources that come underneath of it. We're following this precedent in that CSS sub-resources set here. So CSS sub-resources behave this way, and module scripts now behave this way as well. We want this lightweight client concept. So we manually set the refer string of the request that we make from b.com script.js to b.com script.js. That's the base URL. And so here we can see the request properties in bubble number 3. The current URL, of course, is whatever the URL of the script we're importing is, a.com xjs. And the refer string is b.com. The origin of the refer string is going to be b.com because of the special HTML logic we have. But the client's origin is still a.com because we still have the same environment settings object. It's not this module script is not a fully fledged client. And so if we were to do a traditional same origin comparison, we would determine that this request is actually a same origin request, and we would not redact the refer string. But we ultimately decided that it made a lot more sense to make the origin that's having its information potentially be exposed or redacted be the origin that we perform the comparison against. So in this case, b.com script.js is the URL that might be leaked to a different origin, or might be exposed or redacted is a candidate for redaction in this case, and we want that to be the exact same URL that we use to determine, for the purposes of refer policy redaction, whether or not we should do anything to this refer string. So that's why the web is complicated, and I'm very sorry about it, but that's how it is. So I hope you enjoyed this little presentation. Thank you.